In the last lecture we see the distance of point from line. We see the formula for the distance of a point from line in a vector form. We also see the example without using that formula. Okay. Now we see the examples on distance of a point from line in the exercise 6.2. Okay. Here. Find the length of perpendicular from 2, -3, 1 to the line x plus 1 upon 2 is equal to y minus 3 upon 3 and z plus 1 upon minus 1. Here in the last lecture we see find the length of perpendicular from point to the line in the two ways, okay, by using the formula and direct method, but that method in the vector form. We see in this lecture the third method for finding the length of perpendicular. It is in the Cartesian form and it is very easy other than by that two methods which are we see in the last lecture. Okay, here Cartesian method is very easy from last two methods. Okay, here we can find the length of perpendicular. Here it is a point, suppose it is a P point, it is a 2, -3 and 1. Okay, and it is a given line. It is x plus 1 by 2 is equal to y minus 3 by 3 and is equal to z plus 1 by minus 1. It is a line. We want to find the length of perpendicular, that is the distance. Okay, here. Now it is m, it is a foot of perpendicular. Okay, here we know that PM and the given line are the perpendicular. Here given that the direction ratios of the line, here direction ratios of the line A1, B1 and C1, it is 2, 3 and minus 1. Okay, are the direction ratios of line, and PM and this line are the perpendicular to each other. Suppose the direction ratios of PM, it is A2, B2 and C2, and PM perpendicular to the line. Therefore we can write by perpendicular condition A1 A2 plus B1 B2 plus C1 C2 is equal to 0. Here it is the direction ratios of PM and it is direction ratios of line. Direction ratios of the line are the given, but the direction ratios of PM are not given. PM and line are the perpendicular, but direction ratios of PM are not given. If we know the coordinate of the point M, that is we know the coordinate of the foot of perpendicular, it is a foot of perpendicular, then we find the direction ratios of PM, and then by using this condition we find the value of it is foot of perpendicular and then length of perpendicular. Okay, here A1 B1 C1 are the direction ratios of line, A2 B2 C2 are the direction ratios of M, it is PM, and M is a foot of perpendicular drawn from P from the line. Okay, here M is any point on this line. Okay, so we know that the XYZ be any point on the line, it is a variable point, so we take the variable point, it is M. Okay, and that it is an unknown value, it is a lambda, and by using this condition we find the value of lambda. In the last lecture we see this condition, but in that example we see in the vector form there is a dot product 0, and dot product can also written as here A1 A2 plus B1 B2 plus C1 C2 is equal to 0. It is a dot product. Here first vector it is a 3 cap plus 2 cap plus 3j cap plus minus k cap, and second it is a direction ratios of PM. It is a PM is a vector and PM perpendicular to this vector. In last lecture we see by using the vector method, okay, PM perpendicular to the line, that is PM perpendicular to this vector, and there we take the dot product. Here is also dot product, by here we use the direction ratios, and it is very easy method by the vector method. Okay, here we see this concept. See the concept. Okay, काय करायचे, लाईन दिलेली आहे, लाईनवरचा कोणताही पॉईंट दॅट इज एक्स वाय झेड, इट इज अ फूट ऑफ परपेंडिक्युलर. ओके, पी एमचे डायरेक्शन रेशोज काढा, आणि लाईनचे डायरेक्शन रेशोज ऑलरेडी दिलेले आहेत, आणि दोन्ही लाईन परपेंडिक्युलर आहेत, म्हणजेच कंडिशन ही आहे. याच्यावरून तुम्हाला मिळणार लॅम्बडाची व्हॅल्यू, आणि लॅम्बडाची व्हॅल्यू मिळाली की यम मिळणार, आणि यम मिळालं की तुम्हाला लेंथ पी एम काढता येते, दॅट इज द लेंथ ऑफ परपेंडिक्युलर. ओके, हियर here given line x plus 1 upon 2 is equal to y minus 3 upon 3 is equal to z plus 1 upon minus 1. Okay, here is equal to lambda. Okay. Now its direction ratios are, it is A1, B1 and C1. It is a 2, 3 and minus 1 are the direction ratios of the line. Okay. Then let P, it is a 2, minus 3, 1 be a point, and M be the foot of perpendicular drawn from P to line, it is suppose it is 1. Okay. It is equation number 1. Therefore M be any point on the line, therefore it is from equation 1, from 1 we can write x plus 1 is equal to 2 lambda, y minus 3 is equal to 3 lambda, and z plus 1 is equal to minus lambda. Therefore it is x is equal to 2 lambda minus 1, y is equal to 3 lambda plus 3, and z is equal to minus lambda minus 1. Then x, y and z is equal to 2 lambda minus 1, 3 lambda plus 3 and minus lambda minus 1 be point on line. Point on line 1. Okay, let M be the foot of perpendicular. Let M, it is x comma y comma z, that is M 2 lambda minus 1, 3 lambda plus 3 and minus lambda minus 1. Okay, here it is the coordinates of M, and then we know that PM perpendicular to the line 1. So we find the direction ratios of PM. Now direction ratios of PM, see carefully, direction ratios of PM, it is a P and it is M. Okay. Direction ratios of PM are 2 lambda minus 1 minus 2, x2 minus x1, y2 minus y1, z2 minus z1, 3 lambda plus 3 plus 3, here it is plus 3, y2 minus y1, and then and last it is minus lambda minus 1 minus 1 are the direction ratios, that is A2, B2 and C2. It is 2 lambda plus 3, sorry it is minus 3, 2 lambda minus 3, 3 lambda plus 6 and minus lambda minus 2 are the direction ratios of PM. And here PM perpendicular to line 1, and therefore we can write A1 A2 plus B1 B2 plus C1 C2 is equal to 0. Then A1 2, 3, -1. A1 it is a 2, and A2 2 lambda minus 3, it is A2, plus B1 it is a 3, and B2 3 lambda plus 6, plus C1 it is a -1, and C2 minus lambda minus 2 is equal to 0. Then calculate, it is 4 lambda minus 6 plus 9 lambda minus, it is plus 18, minus 1, it is a plus lambda plus 2 is equal to 0. Then 4 lambda plus 9 lambda and plus it is a 14 lambda. Okay, 4 plus 9 plus lambda minus 6 plus 18, it is a 12, and 12 plus 2 again it is a 14 is equal to 0, and therefore lambda is equal to -1. Lambda is equal to -1. Put the value of lambda, we get the foot of perpendicular. Okay, therefore coordinates of m it is a 2 lambda -1, 3 lambda plus 3, and minus lambda -1. Therefore coordinates of m, we can write here coordinates of m, it is a -2 -1, -3 plus 3, it is a 1 -1. See carefully, -2 lambda is equal to -1, -2 -1, here -3 plus 3, minus, and lambda it is a -1, therefore it is a +1, and therefore m, coordinates of m are -3, 0 and 0, 0, 0. It is a coordinate of m, that is, it is a foot of perpendicular. Okay, here only ask the length of perpendicular, but in the exam we ask the question, find the foot of perpendicular and length of perpendicular. Then foot of perpendicular, it is a foot of perpendicular m. Now we find the length of perpendicular, that is distance between point P and m, that is distance of point P from the line. Now PM is equal to under root of PM, it is a m and it is P. Okay, x2 minus x1, y2 minus y1, and z2 minus z1. Here PM by distance formula, x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square, that is 2 plus 3 whole square minus 3 minus 0 whole square and plus 1 minus 0 whole square. Now calculate, it is 25 plus 9 and plus 1, and then it is under root 35 units. It is the length of perpendicular. Okay, in this question only ask the length of perpendicular, but in the exam ask the question, it is find the foot of perpendicular and length of perpendicular. So it is a foot of perpendicular and it is length of perpendicular. Okay, it is in the Cartesian form. Okay, फक्त एवढं लक्षात राहू द्या, कार्टेशियन फॉर्म तुम्हाला डिस्टन्स या पॉईंटच्या या लाईन पासून काढायचे. ओके, देन कन्सेप्ट काय, तर PM परपेंडिक्युलर टू द लाईन, PM परपेंडिक्युलर टू द लाईन हा कन्सेप्ट घ्या. मग परपेंडिक्युलर म्हणले काय, वेक्टर फॉर्म मध्ये असलं तर डॉट प्रॉडक्ट 0, कार्टेशियन फॉर्म मध्ये असलं तर डायरेक्शन रेशियोज घ्या, दॅट इज A1 A2 प्लस B1 B2 प्लस C1 C2 इक्वल टू 0. मग लाईनचे डायरेक्शन रेशियोज तर दिलेलेच आहेत, दॅट इज A1 B1 C1. आपल्याला डायरेक्शन रेशियोज काढायचे PM चे, तर हा m पॉइंट माहित नाही, तर m पॉइंट इज ऑन द लाईन, देयरफॉर इट इज XYZ, it is XYZ, and by using condition of the perpendicular line, okay, A1 A2 plus B1 B2 plus C1 C2 is equal to 0. We find the value of lambda and put the value of lambda, we get the foot of perpendicular. When we get the coordinates of m, distance between them, it is a length of perpendicular. Okay, here this example by using vector method, okay, we can see the next example. कन्सेप्ट पूर्ण हाच आहे, फक्त हेच वेक्टर फॉर्म मध्ये लिहायचे. हियर डायरेक्शन रेशोजच्या ऐवजी काय येणार, तिथं पॅरलल वेक्टर येणार, म्हणजेच लाईन मधला पॅरलल वेक्टर लिहिणार इथं 2i कॅप प्लस 3j कॅप मायनस k कॅप, अँड देन वेक्टर PM चे हे डायरेक्शन रेशोजच्या ऐवजी वेक्टर PM येईल, दॅट इज 2 लॅम्बडा मायनस 3i कॅप प्लस 3 लॅम्बडा प्लस 6j कॅप प्लस मायनस लॅम्बडा मायनस 2 के कॅप अँड देन त्या दोन्हीचा डॉट प्रॉडक्ट. पुन्हा कन्सेप्ट हाच. ओके, फक्त तिथं वेक्टर फॉर्ममध्ये येणार. कन्सेप्ट पूर्ण हाच घ्यायचा आहे, फक्त हेच वेक्टर फॉर्ममध्ये लिहायचे. डायरेक्शन रेशिओज लिहिण्याच्या ऐवजी वेक्टर लिहिणार, पॅरलल वेक्टर. हा यम एक्स वाय झेड लिहिण्याच्या ऐवजी एक्स आय कॅप प्लस वाय जे कॅप प्लस झेड के कॅप दॅट इज आर बार बी एनी पॉईंट ऑन द लाईन. अँड देन यमचे पोझिशन वेक्टर मीन्स आर बार. पी बार इट इज अ पोझिशन वेक्टर ऑफ पॉईंट पी. अँड देन वेक्टर पी एम दॅट मीन्स वेक्टर पी एम इट इज आर बार मायनस पी बार, म्हणजेच हा वेक्टर येणार. यालाच डायरेक्शन रेशिओज आहेत आय जे केला. हेच सगळे कन्सेप्ट हेच, फक्त यालाच वेक्टर फॉर्ममध्ये लिहायचे. ओके, याच्यानंतरचं एक्झाम्पल पाहू आपण वेक्टर फॉर्ममध्ये. Next example, find the coordinates of the foot of perpendicular drawn from the point two I cap minus j cap plus 5 k cap to the line R bar is equal to 11 I cap minus 2 j cap minus 8 k cap plus lambda into 10 I cap minus 4 j cap minus 11 k cap. Also find the length of perpendicular. Okay, here if the question is asked only find the length of perpendicular, we can use the formula for the length of perpendicular we see in the last lecture. Here it is a bar, it is b bar and it is p bar. Value of p bar, a bar and b bar put in the formula and then calculate, it is the length of perpendicular. But here question is find the coordinate of foot of perpendicular. When question is asked find the coordinates of foot of perpendicular, we cannot use the distance formula, okay, which is given in the last lecture. Here we find the foot of perpendicular. Here this point, okay, it is a given point, okay, see it is a p and then it is a given line. R bar is equal to a bar plus lambda b bar. Now m is a foot of perpendicular. Okay, here m is a foot of perpendicular, therefore pm and line are the perpendicular, that is pm and it is a b bar are the perpendicular, that is a pm and this vector are the perpendicular, therefore their dot product is 0. So we find the coordinates of m. M is any point on the line, that is a variable point, we can take r bar. Okay, here given point, it is P with position vector P bar is equal to 2i cap minus j cap plus 5k cap, and the line is r bar is equal to 11i cap minus 2j cap minus 8k cap plus lambda into 10i cap minus j cap minus 11k cap. Okay, here it is equation number 1. Okay, here r bar is equal to 11 plus 10 lambda j I cap plus minus 2 minus 4 lambda j cap plus minus 8 minus 11 lambda k cap. B, point on line. Okay, here it is a point on the line. Now we consider M is a foot of perpendicular. Let M with position vector r bar be foot of perpendicular drawn from P with position vector P bar to the line 1. Therefore, M, it is a this. M is equal to, it is 11 plus 10 lambda I cap plus minus 2 minus 4 lambda j cap plus minus 8 minus 11 lambda k cap. Now, here PM perpendicular to the line, that is PM perpendicular to this vector. Here we can find the PM, the vector PM is equal to r bar minus p bar. See carefully, it is r bar minus p bar, that is PM 10, it is 11 plus 10 lambda minus 2, that is 9 plus 10 lambda I cap. See carefully, r bar minus p bar, it is r bar, it is p bar, r bar minus p bar, minus 2 lambda minus 4 lambda minus 1, that is minus 3 minus 4 lambda j cap plus minus 8 lambda minus 11 lambda, and it is minus 5. Okay, here 1 minute, it is minus 2 and it is plus 1 here, minus 1. Okay, j cap here minus 2j minus 4 lambda and minus 1, it is a plus 1, therefore minus 2 plus 1, it is a minus 1. Now here minus 8 and it is minus 5, minus 13 minus 11 lambda k cap, it is a PM. Now PM perpendicular to line 1, that is PM perpendicular to the vector 10 I cap minus 4 j cap and minus 11 k cap. PM perpendicular to the line, that means PM perpendicular to this vector, because this vector is a parallel to the line. Here PM is perpendicular to this line, that means PM is a perpendicular to the vector. Therefore dot product of these two vectors, it is a 0, and therefore dot product of PM and this vector, it is 0. It is a PM and this vector. Therefore we can write here 9 plus 10 lambda into 10 plus minus 1 minus 4 lambda into minus 4 plus minus 13 minus 11 lambda into minus 11 is equal to 0. Okay, here dot product of these two vectors, it is a 0, and it is a dot product. It is a vector PM and it is a vector, this vector 10 minus 4 11, 10 minus 4, it is minus 11. Now take a calculation, 90 plus 100 lambda plus 4 plus 16 lambda, then it is minus plus 13 into 11. Okay, it is a 3 and it is 4, 144. Okay, here, and plus 121 lambda is equal to 0. Now calculate 100 plus 16 plus 121. 16 plus 121. 16 plus 21. It is a 37. 137, it is 237. 237 lambda. And then plus, it is plus. Okay, here 90. Here it is 147. It is 147 plus 90, it is a 237 is equal to 0. And therefore, lambda is equal to minus 1. Value of lambda is equal to minus 1. Now, foot of perpendicular, it is this. M is foot of perpendicular. Okay, coordinates of the M. It is M bar, it is this. Therefore, coordinates of M 11 plus 10 lambda minus 2 minus 4 lambda and minus 8 minus 11 lambda are the coordinates. We put the value of lambda. Therefore, coordinates of M 11 minus 10 minus 2 plus 4 and minus 8 plus 11. Therefore, M is equal to 1, 2 and 3. Here are the coordinates. Are the coordinates of the foot of perpendicular. Okay, coordinates of M 1, 2, 3. Now we find the length of perpendicular, that is the length of point P and M, that means the magnitude of vector PM. It is a vector PM. Now length of perpendicular. Okay, length of perpendicular, it is a vector PM. Okay, now we can find first vector PM is equal to, see carefully, vector PM, it is this. We put the value of lambda. It is 9 minus 10 I cap. Lambda is equal to minus 1 plus minus 1 plus 4. Lambda is equal to minus 1 j cap and plus minus 13 plus 11 k cap. Okay, and therefore PM, it is minus I cap plus 3 j cap and plus, so it is minus 2 k cap. It is a vector PM, but length of perpendicular, it is a magnitude of vector PM. Therefore, length of perpendicular is equal to magnitude of vector PM, and that is under root of minus 1 square plus 3 square and plus minus 2 square. It is under root of 1 plus 9 plus 4. It is a 14 units. Okay. Here it is a length of perpendicular 14 units, and it is a foot of perpendicular. Coordinates of the foot of perpendicular are 1, 2, 3, and length of perpendicular, it is a under root 14. When we ask only find the length of perpendicular, we can find directly by using formula or this method. But when we can ask find the foot of perpendicular, that it is only one method. Okay, see carefully, check all the calculations.